I would like to thank Midco Manufacturing for sponsoring my series on Oil Burner Service 101. They were so kind as to send me a P115-10M pump testing manifold kit. It's manufactured by Midco Manufacturing. Check out their products. They have some great products online. I think it's midcomanufacturing.com. Look through their catalog. Their catalog's online. And anything you see there that you would like be interested in, please contact your local wholesaler and tell them that you're interested in Midco Manufacturing products. So this case right here was sent to me, this test kit. And like I said, it is a test kit for fuel oil pumps. And what's really neat about this is it's set up almost like an air conditioning manifold kit. It comes in a really nice solid plastic case with a latch on it. And inside you will see, first off, some adapters in their own plastic carrying case. Now this pump kit does pressure and vacuum. That's why there's two gauges on it. It'll do test your fuel cutoff on it and a few other things that we'll get into. So it comes with a few adapters here. There's a flare adapter. They're just screwed together here. That would be used for the vacuum part of it. Then it comes with a few more brass adapters in another case. And in here what you get, if you look, you have, these are brass adapters for flare adapters to go onto different types of fuel pumps for some of the larger 1/4-inch adapters down to the 3/16, I believe that is. And then you also get some nice Riello adapters. So the metric adapters for the Metron oil burners come with it as well. Look at that. Isn't that beautiful? Nice quality manifold set, if we get it in frame here. Made by Midco Manufacturing. Pump test and vacuum test kit. Glycol filled gauges. You have on this side here, you have the pressure. You've got a gauge from 0 to 300 psi. On the other side you have a vacuum gauge from 0 to 30 inches of vacuum. Isn't that beautiful? You got shut-off valves, service valves on each end of them. Then on the opposite end, we have clear vacuum tubes here for your vacuum, so you can actually see the oil. You can see air bubbles. On the end of that, you have some flare connection, male and female flare connection, 3/8. Now on the supply line, the pressure side, I should say, you have small lines. There are rigid, semi-rigid plastic, because they're high pressure, with nice fittings on the end. You can get your fingers right on those. It's knurled. You screw it right on the ends of the fuel pump. It's a great, and last but not least, it's got a place where you can hang it up. You've got instructions on it right there on how to use it, what it's for. I'm sure you can find all this information on the web as well. Even better about this set here is that when we're done with this set, and I'm done showing it to you what it will do and why you need gauges like this, and we're going to donate them to a technical school, to an HVAC student. But I want to thanks again Midco for donating this to us, and let's go downstairs and see how it works. Okay, I have the pressure gauge hooked up. I don't have the vacuum gauge hooked up. I really wanted to do that, but in the boiler that I have here, the situation, the oil tank is actually built in behind a wall, and the valve is not accessible, at least without rearranging the entire basement. My run here is only about 8 feet. The oil tank is only 8 to 10 feet away, maybe 10 feet. And I know if I hooked up the vacuum, the gauge wouldn't read at all anyway because they're so close. So I'm going to bypass that part, but I'm going to show you the pressure gauge and some of the ways to check the pump and make sure that it's operating right. So we have the red line going to the pump, and we have the yellow line going to the nozzle line. So we just put this gauge in series. Okay, while we're waiting on the boiler to fire, it'll take a minute or so. First test I'm going to do is this shutoff valve here. When the burner fires off, we're going to read our pressure on the gauge. I believe the pump is set at 100 psi, I believe, but I'm not positive. We will find out. First test we're going to do is we're going to take, once the burner is fired, we're going to turn this valve all the way off in the closed position. And then we're going to see, before we get to all the way closed, if the pump loses its pressure, then you have a bad pump. If the valve shut off, with the burner running, the pump should maintain pressure. So let's see if it does that. Okay, the burner just lit, and we're looking at about 140, just over 140 psi, which is great, just what we wanted. Now what I'm going to do is I'm going to slowly turn off this nozzle line, the oil flowing through. We're going to lose our flame. Let's watch the pressure and see what happens. Notice how the pressure maintains? Got a good fuel pump. Let's open it back up. The fire's back off again. Just what we're looking for. Okay, now that we've already established that the pump can build up pressure, what we're going to do is we're going to shut it back off. And we're going to let the burner lock out. After 45 seconds, it just lost flame. We're going to check and watch our pressures and see what happens. When the pump stops running, when the burner shuts off, it still should maintain pressure. It may drop a few pounds, and that's okay. That's considered normal, but it should not drop down to zero. If so, then the fuel cut off inside, or should not. The fuel cut off inside is bad. It should not drop down to zero or lose more than approximately 20%. Okay. There we go. You can see the needle drop just a little bit, but we are holding steady. Now, if the fuel cutoff valve was bad inside the fuel pump, we would see this pressure gauge slowly start to drop. And that means that the oil would be bypassing, because the oil's still under pressure right now, and the oil would be bypassing the cutoff valve, slipping through leaky valve and out the end of the burner, the nozzle, dripping into the combustion chamber, which in turn is going to give you sooting and smoking when it starts up. And as long as that oil is dripping in that hot combustion chamber, you're not getting clean combustion. There's not enough oxygen, so that's creating soot and smoke sticking to the inside of the heat exchanger. So let's press the reset button. Let's open this up. It says it cooled down enough. I have an old style control on here, a thermal style control. There we go. Whoops. On the old style primary controls, CAD cell relays, I have a R8184D 1027 control on this. Old Honeywell control. It still uses heat to trip it out, so it has to cool down a little bit before you can reset it. But there you go. As you can see, pressure's right up there, right where we want it to be. Now the vacuum, if I had the vacuum gauges on, which I wish I had, you would see pretty much no change in the vacuum gauge, because the oil line, like I said before, is so close, we really wouldn't even be able to read a 1 inch. You may see a ½ inch of vacuum. Alright, to check your fuel, to change your pressure in your fuel pump, there is a regulator right here. Take a common screwdriver, find the slot, and if you watch the gauge, if you turn it clockwise, you will increase the pressure. Here's 150, 170, all right? But you're also increasing your gallons per minute, or gallons per hour. So I'm going to take it down to 140. Right on the nose. Midco pressure gauges and vacuum gauge manifold test kit. It's really something you need in your arsenal. You need a pressure gauge, it's so important, and a good vacuum gauge. So everything on this burner, and we know for sure that this pump is working properly and it tests out perfect. There is no question whatsoever that everything, that our vacuums are good, our pressures are good, our cutoff's good. We've tested everything on this. There's one other thing I want to show you when you're done, do your tune-ups or whatever you've done servicing it. A little trick I'll show you. Okay, a little trick I learned a long time ago is after I was done servicing an oil burner, I wanted to check the primary control, make sure that it locked out. That's important, safety control. And I wanted to take, and I had to bleed the fuel pump or purge the air out of the fuel pump. That's something that had to be done. I also had to get the air out of the oil filter because there's full of air. I'd already changed the filter. And last but not least, the oil line. On a one-pipe system, the oil line, the amount of flow rate through the oil line is whatever the nozzle is. It's equal to the nozzle. So if you have a flow rate of a gallon per hour in your nozzle, every hour runtime, you're only running a gallon of oil through your oil line. So it gets a lot of sludge buildup in there, and you really don't get any high velocities to clean it out of oil running through the oil line. So what I find is when I purge it, I can get the air out of the filter, I can get the air out of the fuel pump, I can flush out the fuel lines, I can check for any air leaks in the system that there might be. I can check for cavitation to see if the fuel lines are plugged up, and we spoke about that, pulling the oil apart, and that's all done through a $2 hose. Put your hose on first, open up your bleeder, and then we're going to bleed into here. Now when we're bleeding into our container, what we're looking for is this. We're going to look in the hose. It's important to have a clear hose. We're going to look at the hose. We're going to look for a few things. We're going to look for, first off, the oil is going to be jet black. And we're going to get some air. Now I didn't change the oil filter on this unit for demonstration purposes. I probably should have, but for time I didn't. So you won't see the air come out. But you typically get air out of everything. And then you get a nice fresh red color oil coming through, and that's what you're looking for, that red color oil, and shouldn't be jet black. Now if you start seeing air bubbles, well, that's a given. You know you have an air leak somewhere, something has to be tightened up. But don't confuse cavitation with air leak. Cavitation, a good sign giveaway is that if it's an air leak, when you have the end of your hose and you place it, submerge it in the bottom of the oil, if you're sucking air, you're going to blow bubbles. And when the unit shuts down on safety, it's pretty much the oil is just kind of going to sit there. No more oil is going to come out usually. It's not going to get sucked back in because you're not really running a vacuum. The pump's not straining to pull the oil and creates a vacuum. So therefore, when it shuts down, it just kind of sits there. Now, if it's cavitation, if you're pulling too hard because there's a blockage in your bottom of the tank, the oil line's filled with sludge, whatever the case, a valve off, then it's going to look like foam. It may or may not bubble in the oil. It will not bubble as much because you're not really pulling air. It will not bubble as much as if you're pulling air. You'll definitely see a difference in that. But the key is this, is that when the burner shuts off, and you can either do it by pressing the reset button, or you can do it by just waiting until it locks out. But when it shuts off, this is why I keep the hose submerged in the oil. When it shuts off, it's going to suck the oil from the container back up through the pump because the line is in a vacuum. And when it shuts down, you lose your vacuum and shuts the oil in. So with all that, with one turn right here, we can take and check all that. We can clean our oil lines. We can get the air out of the filter, out of the fuel pump. We can check for cavitation. We can do all that just when we bleed. And we can check for safety, make sure it locks out, all while we're just bleeding the fuel pump. So let's turn it on and give it a shot. Now open up this. See how dark it is? I see no cavitation, I see no air bubbles. Maybe should have got a bigger container. As you can see, it's starting to clear up. I didn't change the filter, so that's one reason why it's really dark. Good timing. It's up to temperature.